Yes, class. Am I audible to all of you? Martin, Sarah, Harsha?
Yes, ma'am.
All right. Now, see, this question says we had started with capillarity. Let's complete this. A glass, YouTube, one or two questions we have to discuss. Then we'll start with hydrodynamics. I want to start with viscosity now. So, a glass, YouTube with diameter 3 millimeter and 6 millimeter. This is a single YouTube. One side is narrower like this. If you see this side, the diameter is 3 millimeter. And if you see this wider side, the diameter is 6 millimeter. This is the same tube. Calculate the difference in water level in the two limbs. Basically, this means some water will go here, some amount of water will go here. But obviously, this is narrower, so a higher level of water will be rising here. So there will be a difference in the levels of water. This will be there will be a difference in the level of waters. So see, this is, let's say, the entire length. This entire length was h1. This entire length is h2, whatever is the water. Just a second. This part only. This part is h2, h1, h2. Then you have the diameter d1 as 3 millimeters. So radius is 1.5 millimeters. Here the diameter is 6 millimeters. So the radius is 3 millimeters. Fine. How will we find out the difference in the height? If you know h1, if you know h2, subtract them, you will get the extra height. You will get this height difference. And cannot you calculate h1? We have studied this, no? We have studied how to calculate height. The formula is this. Formula that we have studied is 2 rho cos theta r rho g. Right? This is the formula which we have studied. So h1 will be C, 2 density. Surface tension. Surface tension is given as 0.07. Cos 0 is 1, so this will be 1 divided by radius 1.5 into 10 to the power minus 3. R, rho density is 10 to the power 3 and G is 10. Similarly, when you are calculating H2, 2 into 0.07 into 1 will be there. But diameter will be 3 into 10 to the power minus 3 into 10 to the power 3 into 10. Now you have to find out H, that is H2 minus H1. That's it. That's the height difference which you have to find out. Fine. This is how you have to calculate. One note point, class. This you can calculate further. I'm not solving it. See, class. When you are taking no height, suppose this is there. A water level is taken. Fine. I have taken a tube here. Now this tube will also be having water in it. This height, we consider this height as the H, right? When I say the water which is above it, suppose this much of water has risen. So I'll take only this H. This is the level of water that has risen, capillarity. Correct, class? Now suppose I have tilted this tube. So some amount of water will go here. Now how will you solve the question? When it was straight tube, you calculated the height above the water level as H. Now when this is above this, now how will you calculate it? So see, what you will do, you will just take the perpendicular segment, the height that is given. You will not calculate this inclination and proper use angle and all. Simply whatever is the separation from this height you will be considering. This separation height from the water level, this height you will be considering. This will be having water in it. So this entire water level, this you will be considering in your calculations. Fine. So suppose if I say, in this case, look here, H is equal to 2s cos theta by r rho g. So H into r, if you multiply height into radius, look, 2 In the above question, which we did, 2 was constant, surface tension was the same for both of them, cos theta was same for both of them, density was same, and g was same. What was the difference that was coming in this question? Only radius and height. These two were different. So you can say product of height into radius, this entire is constant. So sometimes if needed, you can use this also. H1 into R1 is equal to H2 into R2. See, if you directly have used this formula, right now this is not possible here because height 1, height 2 both are unknown. If you only know one of these, if only one of these is unknown, simply you can use this formula. One question we'll see based on this. Easy question, it's not difficult, but first write down this, then I'll discuss. See, this says that water rises in capillary tube. Water rises in a capillary tube to height 2 centimeters in another capillary tube whose radius is 1/3 of it. How much water will rise if the first capillary tube is inclined at an angle of 60 degrees with respect to vertical? Now, what will be the position of water in tube? See, firstly, height into radius is constant, right? H into R is constant. So we say H1 into R1 is equal to H2 into R2. This I told you, this you will use, you can easily use in the formula. Now see, it says water rises in a capillary tube to a height of 2 centimeters. Means this height is 2 centimeters. Let's say this radius is R. Fine. Then it says second height, how much water will rise? H2 we don't know. But it says radius is 1/3 of it. That is R by 3. So H2 is 6 centimeters. Fine. Now see. This is the water tube. This has been inclined. Now see class, be very careful with what is given. If the first capillary tube is inclined at an angle of 60 degree with respect to vertical, this is inclined with respect to vertical. This is 60 degree. Do we take this angle? Right now also when I had drawn, this is theta that you take from the water. If this is no the height, this is the theta that you take. So you will be subtracting 90 degree from it, 60 degree from 90, and you will get 30 degree. This angle you will consider. So be very careful with respect to water level, with respect to horizontal, with respect to vertical, what is being mentioned. Now it's very easy. You just have to find out the what will be the position of water in tube. You have to find out length. You have to find out this length. This length. This length. Now see. Sine 30 degree will be equal to height upon length. So this is half will be equal to 2 by L. So length is 4 centimeter. Position of water means this much. Not this total length of tube. This means the length of water. So this triangle that has been formed between water level, theta and height. And why are we using 2? Why not 6 centimeters? 2 heights are given because it is saying if the first capillary. Fine. Write it down. Then we'll start with viscosity.
So, ma'am, the rise in the water, even if it's straight or inclined, is the same.
Rise in water or?
Ma'am, even if it's straight or inclined, it's the same.
It's the same. It's the same. That's what I was telling you. Height, this inclination will be same. This length can be different, which you will calculate through this triangle. But this height will be the same.
Okay.
Yes, see, position does not mean the inclination or the height. Position means this length. So whenever position of water is asked, status of water is asked, or up to, or the length of water is asked, in all cases you will find the length.
Okay.
Still writing. I don't know.
Done, all of you? Okay. Now starting with hydrodynamics, so we'll be now talking about the flow of the fluids. Right now, we didn't consider velocity, acceleration, any of these terms, right? Now we'll be considering the flow of the fluid particles. Now, see, the first thing that you have to understand, that friction force we have studied. So here, no, we'll be talking about fluid in detail now because we are talking about its motion. The branch of physics which deals with the study of properties of fluids is known as hydrodynamics. Now see. So we'll be studying about these in detail now. Because when you're talking about the motion of fluid, you have to have the knowledge about its each layer. So I am writing each layer separately so that you can focus on it. Now see, when the fluids flow, suppose that this entire fluid, this is moving with the velocity v. Now see, what will happen? These fluid layers will flow forward, right? This will flow forward, this will flow forward, correct? All these will flow forward because the velocity is there. So during this motion, what happens? The way not two objects because of irregularities get rubbed to each other when they are in motion. Similarly, this will also be rubbing. These two layers will be opposing their flow. There will be a force which will oppose their motion. It will provide a resistance. So backward in the opposite direction, the way we have friction force, this force is known as viscous force. Or you can say this is known as viscous drag. Fine. So there is an opposition. The best example you can take is take two. If I take two containers, if I fill with one with water, one with honey, and see, if you rub water is very smooth. It slips off and it evaporates. Whereas in case of honey, do you see there's a stickiness, there is a resistance if you will be rubbing honey in your hand. There will, if you see glycerine also, when you will be rubbing glycerine in your hand, you will see a slight, you will feel an opposition when you are moving it. Rub water, smoothly it will flow. Rub honey, it will be providing you resistance. Because viscous force, the coefficient of viscosity is more in honey as compared to water. So this opposing force in fluids, the friction force in fluids is basically known as the viscous force. So what happens? Individual layers will be moving. So viscous drag, backward dragging force is developed which opposes the motion of the liquid. It acts tangentially on the layers. When a liquid or a fluid flows, a backward dragging force or viscous drag is developed between its layers that retards the motion of the liquid. The viscous drag acts tangentially on the layers of liquid. Fine. Now see this, let's see in detail. Suppose this is one layer of liquid, this is one layer of liquid, two layers I've taken. So they must be separated. Let's say this separation, this is dx. The separation between them is dx. The area of this surface is A. Fine. This is the area is A. The separation between them is dx. Let's say they are moving with velocity v. Fine. Viscous force will be acting on the backward direction. Fine. Now see, this is the left hand side, this is the right hand side. Left hand side viscous force is acting, forward it is moving. So when the viscous force is acting behind, this will be moving forward a little, this will be moving a bit behind, but there will be a difference between them. Fine. So let's say the change in velocity, it's a very small dv. There's a very slight change because see, if two layers are moving and there is a viscous force acting, something is opposing it. So one will be moving slightly a bit forward, sometimes a bit backward. So this change in velocity, we have taken it as plus dv just for calculation purpose. So velocity, area, separation, viscous force. All right. And see, all the layers are overlapping. So area is same. dv is the change in velocity when positioned by dx. dv over dx becomes velocity gradient. Now look, you don't have any derivation here. Just remember, viscous force depends upon few things. Firstly, it is directly proportional to the area. It is directly proportional to this velocity gradient, that is dv over dx. Fine. So when you combine, this is directly proportional to a dv over dx. Here the constant term that we use is eta. This is the coefficient of viscosity. So eta a dv over dx. This is the formula of viscous force. What are the terms in this? See, this is the viscous force. This property of fluids is known as viscosity, and the force that acts is known as viscous force. This is eta, which is the coefficient of viscosity. This determines how much viscous force will be there. See, this is also depending upon the nature of material. Water, it's different. Honey, it's different. Glycerine, it's different. Oil is different. Oil is a little more viscous than water, but less viscous than honey. So it depends upon nature of material. This depends upon the nature of material. Second, it depends upon temperature also. This is depending upon temperature. You increase the temperature, viscosity will increase. This is area. A is area. dv is velocity. ds is the thickness. And both of them will combine and give you velocity gradient. This is what you have to remember. Fine. This is what you have to remember. Like I'll give you an example also. The increase in velocity divided by the distance over which this change occurs, dv over dx, is called the velocity gradient and is measured perpendicular to the direction of velocity. Suppose this is moving with 10 meters per second, their separation is 5 millimeters, area is 2 meters square, and okay, coefficient of viscosity is SI unit is decapoise. I'll tell you. This is
Ma'am, delta x is the thickness.
thickness means the separation between the layers.
Okay.
Thickness means the separation between the layers. Because why have I used the word thickness? Because in some questions I have seen the thickness of the layers is given like this. So that's why just be aware, thickness, if the term is mentioned, it means the separation between the layers. And this is very small. How much separation will be there? We see fluids collectively. This occurs at the macroscopic level. So see, if you have to calculate viscous force, so eta area dv over dx, 10 into area is 2, velocity is how much? Velocity is 10. See, this is at rest. Sometimes you have to subtract also. See, one layer is at 10 meter per second. If second one is at rest, understanding? Second one is at rest. So this is 10 meter per second. 10 minus 0 if you will take the relative one. All right. And this is getting divided by the separation 5 millimeters. This is the separation is 5 millimeters. 10 to the power minus 3. Newton will be the answer. Noted down, proper questions we will see. And coefficient of viscosity's definition also will come. First write it till here, then we'll see.
Area of both the layers will always be equal.
Same. It will be same. If I am talking about this particular segment, so I'll be considering this segment only. What is happening to this segment will be considered in another segment. Whichever overlapping area we always take. That's I've mentioned also. When you will write, you will see. It's always overlapping area. See, this question says you have to calculate the horizontal force required to move a metal plate of area. So area is given with a velocity. Velocity is also given with an area is 2 into 10 to the power minus 2 meter square. Velocity is 4.5 into 10 to the power minus 2 meter per second. When it rests on a layer of oil, see this much thick. This I was mentioning you, Harsha. Whenever it says thickness, it means the separation between the layers. So dx is 1.5 into 10 to the power minus 3. Coefficient of viscosity of oil, eta, is 2 Newton seconds. This is seconds per meter square. So this will be when we have to calculate the viscous force, horizontal viscous force, this will be eta A dV over dx. So this is 2 into 2 into 10 to the power minus 2, velocity 4.5 into 10 to the power minus 2 by 1.5 into 10 to the power minus. See, this you can solve further. What will it be? 4. This gets cancelled. 10 to the power minus 3 as it is. This will become 12. So minus this becomes minus 4. So answer will be 12 into 10 to the power minus 1, 1.2 Newton. This should be the answer. Please cross check also. So see, this says that definition of eta, what you have studied. This says that coefficient of viscosity of a layer is defined as the tangential force required to maintain a unit velocity between two parallel layers of unit area. Means if you make in this formula, no, eta formula, if you make everything as 1, force is also 1, area is also 1 meter square, velocity gradient also unit, so it will be equal to the force, right? Fv is equal to eta A dv over dx. If everything is 1, all these things are 1 unit, so eta will be equal to force. This is what it is saying. It's defined as the tangential force required to maintain unit velocity gradient between two parallel layers of unit area. And for ideal, it's 0. It's inversely proportional to temperature. This I already told you that if you will increase, this will decrease viscosity. And but remember, this is valid for liquids. For gases, it is directly proportional. Whenever we are talking about fluids, we do not talk only about liquids. Fluids means combination of gases and liquids. Also, a coefficient of viscosity when we are defining. Unit of viscosity. See, when we are talking about unit of viscosity, F is equal to this is equal to eta A dV over dx. So what is eta equal to? Fv into dx divided by area into dV. Put in the units. Force is Newton, dx meter, area meter square, velocity is meter per second. Second will go up. So what we are getting? Newton seconds per meter square. This is equal to what we write as decapoise. And CGS unit is poise. Decapoise and poise. And deca, you know how to convert 10 to the power 10. Just multiply by 10. Not 10 to the power anything. Just multiply by 10. So I hope you have understood this fact. Effect of temperature for liquid and gases. So this is inversely proportional to temperature and this is directly. This is important. That's why I am rewriting it. We'll see question, but first write it till here.
The SI unit is Newton second per meter square of the coefficient.
Yes, Harsha, you're asking something?
The SI unit of the coefficient is Newton second per meter square.
Yes, yes. Or you can simply use decapoise.
Okay.
See, this question says a metal plate of 0.1 meter square is connected to a 0.01 kg mass via string that passes over an ideal pulley. So pulley is there. A block is there, string is passing through it, and here is a mass. Liquid film thickness of 0.3 here. This thickness is 0.3 millimeters. Velocity 0.08 meter per second. Coefficient of viscosity of liquid. See, force, basically force you have to find out. What is unknown? Unknown is coefficient of viscosity. So here the tension or the force that will be acting. This tension will be equal to the viscous force and this tension will be equal to the weight. So both the tensions are same. See, if tension is equal to mg, correct? If tension is equal to mg, viscous force is equal to tension. So we can say viscous force is equal to mg. Yes, Sarah. It's just towards the end, and now you have to substitute in the value. You can calculate it later. So eta will be f dx a dv. So this is mg.
How are both the tensions same?
Hmm?
And how are both the tensions same?
Same string. It's the same string.
Okay.
It's the same string. That's why. So when we put in the values, eta will be equal to how much it's given? Metal plate 0.01 kg. 0.01 into 10 into dx is 0.03. 0.3 millimeters. So into 10 to the power minus 3. Area is also given. Area is metal plate of 0.1 meter square. So this is 0.1. Velocity is 0.085. 0.085. Fine. So this you can solve. See, if we write it like this becomes 0.1 into 3. No, 0.3. 0. Into 10 to the power minus 3. 0.1, 0.085. This will be cancelled. So around 3.35 into 10 to the power minus 3 decapoise should be the answer. Write it down. Question you have written?
Yes.
Okay, write down the solution. Then once completed, we have this completes with the viscosity topic. Now we'll start with Stokes' law. In the next class, I'll start with Stokes' law on Thursday. Okay, you can leave once you have completed it. Thank you so much, class.
Okay.